This clip is about a Greek mathematician dude called Pythagoras, who actually discovered something reasonably interesting but very, very useful about right-angled triangles. What he discovered was that if you take a right-angled triangle and take the two sides which actually form the right angle here and square each of them, like so, and so there, the result is if you add both of these areas together, believe it or not, it will equal the square of the longest side, the hypotenuse, this side. So this added to this in terms of area, believe it or not, equals this area. I'll try and prove it to you in a moment, but it is actually the same for any right-angled triangle. The two sides which form the right angle, you square them. This added to this in terms of area, in fact, equals this area. Let me try and prove it to you now. Let's take this example here. The units are not important at this stage, so let's just count squares. 1, 2, 3, 4 squares across this side, part of which forms the right angle. 1, 2, 3 squares up on that side, which form the right angle. So let's square each of these sides. Let's start with the bottom one. A 4 by 4 square formed on that side. Then the vertical, a 3 by 3 square this side. So what we now have is our 16 squares here. If we add that to our 9 squares here, that gives us a total of 25. That should be equal to this side squared. So here is that side squared. And in fact, we can see that the length of it is 5 squares by 5 squares. And that is actually 25 squares within this square here. Just to prove that it's equal, here's my 9 squares on there. I'm going to take a pair of scissors to the other one. There's part of it. And finally, these last little bits here. And there we are. So just to write down the final dimension, that was 5. So what Pythagoras discovered was that this side squared, 3 squared, added to this side squared, equaled this side squared. Just to confirm that's true, 3 squared is 9, added to 4 squared, which is 16, does in fact equal 25, which obviously is 5 squared. Now I did say this was really useful, so let's apply it to a real problem. Let's try for some home improvements, shall we? I've got my house. I'd like to employ Bob the Builder here to put an extension on my house, having a sloping roof like so. Now there are certain dimensions I know, but not all of them, and I can use Pythagoras' theorem to work out all of my dimensions. Let's imagine I know the width of my extension to be 4 meters, and the height of my extension, where the roof is, to be 5 meters. Now I can use Pythagoras' theorem to work out the length of the piece of timber that I would need to form the slope on the roof. Now this is actually called the hypotenuse, and typically that's called h. Now Pythagoras discovered that h squared is equal to 5 squared plus 4 squared. So let's work out some numbers. So h squared is equal to 5 squared, which is in fact 25, added to 4 squared, which is in fact 16. And this gives me a total of 41. Remembering that this is h squared, not h. So in fact, h on its own, using the inverse operation, would in fact be the square root of 41. And that, we can use a calculator. And this would give us an answer, a rounded answer, of 6.4 meters in this example. So h here would equal 6.4 meters. I hope that helps.